Hello and welcome to another video. So in this video what we're going to do is going to have a look at the unit circle again, and we're going to come up with a few more trigonometric identities as well. Now back to what we had originally with a point at the center O and let's say a point P, and obviously it's a unit circle, so it's got a radius of 1, but let's suppose we call this angle theta. And let's suppose we have the same angle theta this way. Okay, let's call this negative theta. We'll call it negative because we're going clockwise, right? So positive is going anti-clockwise and negative is clockwise. And what we can sort of see here is that if I had cosine of theta, which again is the x value, that would sort of give me a value, right? So if I had the cosine of theta, that would actually be equal to the cosine of negative theta. And if I had the sine of negative theta, which is over here, that's actually equal to the negative sine of theta. And you might ask, well, how does that work? Well, first of all, we can sort of see that cosine of theta over here gives us the value of the x-coordinate over here. However, that x point is also the same for negative theta, so that's how that bit works. But if you take the sine of the angle at point P, which is the y-coordinate corresponding to here, for negative theta, that sine angle corresponds to here, so they are not the same. And that's why you have this identity, which is the sine, the cosine of theta is going to be the same for the negative angle. However, the sine of the angle will be negative the sine of the positive, right? So that's sort of two identities there. Now let's have a look at another example. Suppose I've got something like, say, sine of 31 pi on 3, and we wanted to evaluate this. Now, as we know, that's in radians, so how would we do that? Well, first of all, we know that pi will always be 0 when it comes to revolutions, right? So when it comes to 2 pi or 4 pi or 6 pi, we know that it's going to be 0. So first thing you want to do is simplify that. So 31 pi over 3. This can really be written as 30 plus 1, because that's 31 times pi on 3, right? And if we sort of take it as that, we've got sine of 30 plus 1 times pi on 3. Now that's really the same as sine of 30 pi on 3 plus pi on 3. And that's equal to sine, because you can simplify those, going back to basic fractions, 10 pi plus pi on 3. And that is the sine of pi on 3. Sine of pi on 3 is sine of 60, which is root 3 over 2. So that's sort of how we go about that. So that's sort of an example of how you can evaluate basic sort of values when given in radians. And I'll see you in the next video.